In this video, we're going to discuss the velocity of money and the quantity of money equation. So the velocity of money is the amount of times a dollar gets spent in a year. So imagine that at the beginning of the year, I have $1 in my pocket, and around March or April, I decide to go to a festival, and at the festival, I buy a funnel cake. And when I buy the funnel cake, I give the dollar that was in my pocket to the man working the funnel cake stand. So I've spent that dollar one time, and that man takes the dollar, and eventually over the summer, he decides he wants to go to Kings Island. So when he goes to Kings Island, he spends that dollar on his admission ticket to Kings Island. And one of the employees at Kings Island eventually gets that dollar, and they spend that in the fall on a nice pumpkin spice latte. Okay, so the dollar has been spent 3 times, so the velocity of money for this dollar would be 3. The quantity equation of money states that M times V equals P times Y, where M is the money supply, V is the velocity of money, P is the price level, and Y is the value of all final goods and services. So we have money times the amount of times that each dollar is spent equals price times real GDP or nominal GDP, right? So we have money times the amount of times each dollar is spent, which would give us nominal GDP for consumers, and we have price times the number of goods that are produced, which is just nominal GDP as produced by producers. So we can also write M times V equals P times Y equals nominal GDP. And we already talked about this a little bit, but the velocity of money in this case would be 3. Since I spent the dollar once, the funnel cake salesman spent the dollar once, and then the worker at Kings Island spent the dollar once. So we've spent the dollar 1, 2, 3 times. Let's go through a quick example of the quantity of money equation, and we'll calculate the velocity of money here using 2 different values for M, M1 and M2. We have M1 in the United States in 2016, as well as M2 in the United States in 2016, and the nominal GDP of the US in 2016. So if we're going to use M1 to find the velocity of money here, we can use the equation where M times V equals P times Y, or nominal GDP, right here. And we plug that in. We plug in M1 for M, nominal GDP goes in for nominal GDP, and we calculate this and get V equals 5.73. We can also use M2. M2 is everything that's included in M1 plus some other things. So if we use M2 to calculate the velocity of money, we should get a lower velocity since our money supply is now higher. And in fact, we do. We're dividing by a larger number here, so the velocity of money will fall. Velocity happens to be determined a lot by technological advances, and the further we distance ourselves from cash, the more likely people are to spend money. So with the advent of things like the ATM, you no longer had to go into a bank to withdraw cash, and you could spend cash quicker because you could just drive through and get money, or walk up to an ATM on the street and get money. And then debit cards, and now we have Venmo and the Cash App and Zelle and all these other things that you can do on your phone where you don't even have to use dollars and cents at all. These technologies are really just allowing people to conduct business and not carry cash, which means we can transfer a lot more funds a lot quicker without using actual money. So the velocity of money increases with increases in technology.